Hi everyone. Today we're talking about the idea of solving one-step equations. Go ahead and follow along with your set of notes and make sure to write down every step so that you can understand the process. Okay? Here we go. The equal sign looks like this. It means that both sides of an equation are balanced or the same. Equation are balanced or the same. Okay, so let me give you an example here. Okay. So let's say we were talking about a seesaw. Okay, and then this is the middle of the seesaw. Let's say I had a few kids on here. Right? Let's say I had 3 kids on this side of the seesaw and 3 kids on this side of the seesaw. That means to keep it balanced, I need to have the same number of kids on each side. So let's say I add another little kid, one of these little circles on this side of the seesaw, then I need to add another little kid on this side of the seesaw to make sure everything is balanced. Let's say I take off 2 of these little kids. That means that I need to take off 2 of these little kids to keep it balanced. Otherwise, we're out of balance. If we had an out of balance seesaw, it would look something like this, or like this. Okay? So I just want you to keep that in mind as we're going through today because we need to keep equations balanced. Alright. So today we're going to be learning about a vocabulary word that is called inverse operations. Okay? So the inverse operation of addition is subtraction. And vice versa. So that means the inverse operation of subtraction is addition. Okay? Now addition and subtraction of the same number create a zero pair. So that means if I have 3 minus 3, that makes 0. If I had negative 5 plus 5, that makes 0. Okay? That's what I'm saying. Alright? So, let's look at these first 2 examples. Example 1 says x plus 8 equals negative 19. Now, what I like to do is to make sure that everything is balanced. Right? So I'm going to start with my equal sign. That is the middle of my problem. That is my balance. Okay? I'll bring down my equal sign. Now my variable here is x. Remember, a variable is a letter that represents a number. So this is actually what I'm trying to figure out. In example 1, I'm trying to figure out what x is equal to. Alright. Now right next to the x, I see add 8. I need to get rid of that adding 8. So what I'm going to do is I'm going to use the inverse operation. The inverse operation of addition is subtraction, as I already know. I'm going to subtract 8, but I've just created an imbalance, so now on the other side of the equal sign, I need to also subtract 8. Now this is convenient because positive 8 and negative 8 create a zero pair. So I just made 0. So now x is equal to negative 19, subtract 8 makes negative 27. If you need to check your number line for that, that is okay. Double check it. X is equal to negative 27. Alright. The second example says negative 7 equals y minus 5. So this one's a little bit different just because the variable is on the other side of the equal sign. I'm going to do the same thing. I'm going to draw a circle around my equal sign to make sure I know where my middle is. And then I'm going to also identify my variable. So in this case, my variable is y. So that means I'm trying to figure out something, subtract 5 is equal to negative 7. Alright? So right next to my variable, I see subtract 5. This is the side that I want to start on, meaning I need to get rid of that subtract 5. So inverse operation of subtraction is addition. However, if I add 5, I just created an imbalance, so I got to add 5 little kids on the other side of the seesaw. -5 plus 5. Again, I've done something convenient here. I've created a 0 pair. So now I've got -7 plus 5 is -2. And all I'm left with here is y. So -2 equals y. And that's my final answer. Alright, let's keep moving. Now that we've done addition and subtraction, we want to talk about multiplication and division. So the inverse operation of multiplication is division. And vice versa. So that means the inverse operation of division is multiplication. Multiplication and division of the same number create the number 1. So they don't create 0, but it creates 1. So let's say I had 7 divided by 7, that makes 1. If I have 1/8 times 8, that creates 1, right? Because I can put this over 1. Okay, so let's go ahead and try some of these problems. Example 3 and example 4 both have to deal with multiplication and division. So example 3 says 9z equals -72. Remember, if you look at 9z, that means 9 multiplied by z is equal to -72. Alright, but I'm going to follow the same steps. I'm going to find my middle for the equal sign, and I'm going to label my variable. In this case, my variable is z. So 9 multiplied by z equals -72. I think to myself, there's a number that's attached to that z, which currently is that 9. So 9 multiplied by z equals -72, so I need to use an inverse operation. The inverse operation of multiplication is division. So I'm going to divide 9. However, I've just created an imbalance. Division also creates an imbalance. So I need to divide 9 on the other side of the equation. Now, this is convenient because 9 divided by 9 creates a 1. I'm left with z equals -8. So that's -72 divided by 9. Okay, and now this last example for kind of just the basics of inverse operations. Example 4 says x divided by 3 equals 8. I'm going to start off the same. My middle here is the equal sign. My variable is x. And now I need to use an inverse operation. Well, x is being divided by 3. So what's the inverse operation of division? I ask myself, and I know from my notes that that is multiplication. So that means I'm going to multiply by 3. Now I just created an imbalance. I just multiplied the number of kids on one side by 3. So now I need to multiply by 3 on the other side. You want to think about this as multiplying by 3 over 1. Because now you see that you've really got 3 over 3, which creates 1. So now you're left with x equals 8 multiplied by 3, 24. Okay? Okay, let's move forward. We're going to go through these next examples a little bit more quickly. Make sure to follow along and ask me later if you have any questions. Here we go. Example 5, 6, 7, 8. Here we go. So, example 5 says y subtract 6 equals -13. Again, I'm going to find my equal sign. That's my middle. going to find my variable, which is y in this case. I see y subtract 6, so I need to use the inverse operation of subtraction, which is going to be addition. I'm going to add 6 to both sides of the equation. That's convenient because I've just created a zero pair, meaning y is equal to negative 13 plus 6, which is negative 7. I've gotten the variable by itself, so I've solved my equation. My example 6, I find my middle, which is the equal sign. Okay. Find my variable, which in this case is x. And I start using inverse operations on the side of the variable. So I see x add 15. I want to use this inverse operation of addition, so I'm going to subtract the 15 so I can get the x alone, and subtract 15 on the other side to keep things balanced. I end up with a zero pair here, so x is equal to 9 subtract 15, which is negative 6. Again, if you're having trouble doing some of these subtraction problems, you want to come in for tutoring. Example 7 says negative 24 equals 4z. Now remember, with this situation, that means 4 multiplied by z. Again, I'm going to find my equal sign, find my middle. In this case, my variable is z. I want to get away anything that's hanging onto it. So 4 multiply z. I'm going to use the inverse operation of multiplication, which in this case is division. I'm going to divide 4. I have to divide 4 on both sides to keep things equal. I've just created a 1. So now I'm left with 1z is equal to negative 24 divided by 4, which is negative 6. Okay? And this last example on this slide says 4 equals n divided by negative 7. I find my middle, that's the equal sign. Find my variable, that is n. And then I decide which inverse operation to use. Now it says n divided by negative 7. So inverse operation of division, you got to multiply negative 7 to both sides. Now this is a common mistake. People want to multiply a positive 7. You want to multiply a negative 7 or the same sign, because negative divided by a negative now creates a positive 1. So I'm left with n equals negative 7 multiplied by 4, negative 28. Okay, and let's go to the next slide for the last 4 examples. With all of these, you should be realizing it's just one step to complete all of these, just one inverse operation. So we're going to keep going. Example 9, equal sign, my variable. Now I see x subtract 8. I want to start on this side. I want to get rid of this subtract 8. So I use the inverse operation, which is adding 8. I want to keep things balanced, so I add 8 on the other side. I've just created a zero pair. Now I'm left with x equals 27. That was example 9. Example 10 says negative 8 multiplied by r equals 72. Find my middle. Find my variable, that's r. Now I need to use an inverse operation. Now this says negative 8 multiply r. So inverse operation of multiplication, I'm going to divide negative 8. I must do it to both sides of the equation to keep things balanced. This is convenient. I've just created a 1 pair. So r is negative 9. Make sure you follow your rules. Positive divided by a negative is a negative. Example 11. Find my middle. Find my variable, which is n in this case. Start on the side of the variable, which is n add 15. I see addition. I want to use the inverse operation, which is subtraction. So I subtract 15. I want to keep things balanced, so I subtract 15 on the other side. I'm left with negative 6 is equal to n, because this creates a zero pair. And then finally, the last example, here's my middle, the equal sign. I find my variable, which is m. My C division is being divided by -7, so I want to use the inverse operation, which is multiplication. Remember, I multiply the same sign, so I'm multiplying a -7 to both sides of the equation. This leaves me with -63 here. -63, sorry, my pen's cutting out, is equal to 1n. Okay, thank you for your time. If you have any questions, please come in for tutoring.